case number 2. We have f of x is equal to x to the 2/3, and we're interested in whether or not the derivative exists at 0. Okay, so x to the 2/3. There's another way to write that. We know from algebra class that rational exponents are really the same as radicals, where the denominator of the rational exponent is our root, and the numerator of our exponent belongs to the variable underneath the radical. So this is the same thing as the cube root of x squared. So let's take a look at the cube root of x squared, particularly when x is equal to 0. So I bring the calculator back in, and slide this over just a little bit, there we go. So I have the cube root of x squared, and I'm going to do zoom 4 again. And when I do so, you get sort of a almost like a seagull that you would draw in a child would draw in a landscape picture there. So we're interested in x is 0. We want to see if we can get a line, the graph to turn to a line when x is 0. So we're going to have to zoom in. So zoom, we're going to zoom in right at x equals 0. So I'm going to hit enter. And when I do so, here it comes. It's even steeper now. Okay, that's not good. We're not turning it into a line. Let's zoom in some more. When we do so, again, we see that we are not getting a line here. We're getting something else. And I'm hitting enter one more time, and we see it's getting steeper every single time. So basically, again, the slopes from the left are negative. The slopes from the right are positive, so the limit from the left is not the same as the limit from the right, and therefore the limit of the slopes, i.e. the derivative, does not exist. Right. So what is this called? Well, this is called a cusp. Right? Basically, it's when a curve hits a line, and again, it makes a sharp point. Okay, we see the sharp point right there, but it's not considered a corner. Corner is the intersection of two line segments, and what we have here is a cusp because of the curves that are involved. Okay, so a cusp will happen for any situation where we're looking, where we have an even numerator and an odd denominator. Okay, so for any rational exponent where we have an even numerator and an odd denominator. Okay, and so what ends up happening again, and this actually, cusps can happen in multiple ways. We can also have a cusp which looks, it can be curved, and then it shoots off with a line. Now this is not a cusp that's caused by an even numerator and an odd denominator in the exponent, but it's a curve combined with a line segment. This is actually a piecewise defined function. But in general, what value of x causes a 0? Well, 0 to this 2/3. That's why it happens that we have a point of non-differentiability. We're not differentiable at f prime when x is 0.